All right, it's another quick and dirty one. We're over here messing with the cousin's golf cart, which means something's wrong with it. So this video is for anyone who's got an EzGo golf cart, 36 volter, and you put it in forward, it clicks, don't go nowhere. And additionally, you put it in reverse and it clicks, don't go nowhere. That's the actual model number if that's what you're interested in. Now, the first thing you should check is the batteries. And I know it's not the batteries because I literally just replaced 3 of them and tested 3 of them yesterday. So it's something else. Now, the immediate next thing in the chain is this 36-volt White Rogers solenoid, which shunts power from the battery to this controller jobber guy that then sends it down over here to this the contactor for the reverse forward shifter. So it's an electric vehicle, so it's really dirt simple. So I need to check that solenoid and see if something's wrong with it, because I have my suspicions. Because generally solenoids are not supposed to leak black tar. All right, so just real quick for posterity's sake, got it hooked up negative to positive, and we're getting 37.5 volts. So we have plenty of charge in the batteries. I mean, those 4 are all 6.4 and these are all 6.1. They'll even out with a charge. The trouble is when we come down in here and we hook this guy to the outbound power cable coming out of that solenoid, with the engine off, we're getting 1.7 volts for no reason. That's just a parasitic draw, which solenoid is not supposed to do. Additionally, when we hammer on the accelerator, and don't do this when you're testing a car. I already know this don't work, but 21.2 is not 37.5. Wow, and just look at that fall. So yeah, we're missing a good like 40% of the voltage, and it's just storing that as capacitance for some reason. So that's not a bueno, and that's directly from the battery to the outbound terminal. Now, if we connect this to the contacts for the solenoid, you see that we're not pulling any voltage going from that red lead to that black lead. And so that is the actual circuit that energizes the solenoid. But if we add power, we get the full voltage. Well, 35.9, close enough. So the solenoid is getting full voltage, but, and you know, these are literally just, this is a wire that just goes from that solenoid to this guy. I gotta really learn these terms, but it's the magic black box that makes the power go. So this wire is going nowhere, and this wire right there literally just comes right down up to the positive terminal. So there's nothing in between those two. So the only way that I could be losing voltage between there and there is through this solenoid, because that's it. So that is the new problem child that we're going to have to tackle. So there was, in fact, a bad battery, because I went and checked it and had one battery that was sitting at 4 or 5. So we had to get a new battery anyway, which is great because I literally just got a new battery the other day. As you can see right there, that guy just got that 2 weeks ago. And then 2 weeks later, wouldn't work again. Came out here, another bad battery, went and got that. My cousin just said, the heck with it. We're at 4 batteries, might as well just do the whole lot of them. And now we got a bad solenoid on top of that. So this golf cart has just been an absolute basket case. But anyway, we'll get it fixed. It's a $30 solenoid. Might even be a $20 solenoid if I get the cheapest Chinese one, but it's probably going to be $35 after tax and whatnot. So we'll get that on order, and maybe, just maybe, this thing will be ready to go. It's got 6 new batteries at this point. Okay, but first, one last thing that I needed to check just for my peace of mind before I jump down a rabbit hole. So I have connected from the outside of the solenoid directly to the negative side of the battery stack, and we got full voltage. So there's not an issue with this wire, because every once in a while you get a battery cable like this that'll get internal corrosion, and so you won't actually get full voltage or full amperage flowing through the cable itself. So it'll look like you have a part that's bad, but in actuality you just have corrosion in the cable. But that does not appear to be the case here. So we are going to take that black tar as a sign and order up a new solenoid, get that in, and hopefully it should be a fairly simple swap after 30 minutes of diagnosis, and then a week of waiting, and then another 30-minute fix. So anyway, We shall see. All right, so I went to check things again, and there is just steadily more power flowing through this solenoid every second now, which is interesting. So, weird. That's strange. Yeah, so that's not how a solenoid is supposed to work. It's supposed to not let power go through it. So now there's just randomly like 5 volts just flowing through the solenoid with everything off. Okay, yeah, definitely solenoid bad. So I'm gonna disconnect that so it doesn't kill the batteries, and yeah, we'll get this sucker swapped out. Alrighty, new solenoid is in, so should just be a simple matter of getting in there and just transferring all the components from one end to the other one, and hopefully should not have any issues. But pretty much what we're gonna do is just, you know, take everything off and then put it right back where it was, and hopefully that's all we got to do. All right, so she is in there and back together, and I did actually check it, and it does go forward and backward. So it's working. So it was indeed the solenoid. One other thing I noted while I was in there is that actually the outbound lead on the old solenoid was loose, just by a little bit. So that could have been what finally was the nail in the coffin, but the solenoid was definitely bad, so it needed to be done anyway. I mean, just look at the dang thing. It's not supposed to be leaking black tar. But anywho, we are good now. Also, I just realized this is a retrofit. This is a hack. The old solenoid is right there, which is what the solenoid is actually bolted to. I don't know if you can see that, but yeah, there's the old solenoid that used to be. So this is a retrofit that somebody did a long time ago when they did all of this farmer wiring in here. So this isn't OEM, so I'm sorry anybody who's trying to figure this out in an OEM system, but at the very least, this is how you can work around it. Or if you also have, you know, your system already with a farmer workaround on it, how you can repair that. But anyway, I'm gonna go take her for a rip real quick, and with any luck, it's not gonna break on me. Alright, does she have full power? Oh yeah, she goes! So we're fine now. Good deal. Top off the tires though. That's gear oil. I think I know what I'm gonna be helping my cousin with next. So stay tuned for that. Good, she takes a charge too. Well, on a quick aside, I just like confirming that things are in fact the failure point. So I just have the old solenoid on the bench, and I just popped the cap off of it. And as you can see, there's goo in there, and there's not supposed to be goo in there. So I'm gonna see if I can get this whole stack out of here, and see just what the heck is going on. All right, so the failure is different than what I thought. The asphalt insulation did not melt. It was actually this kind of hard rubber, Bakelite, whatever you want to call it, insulator that's on the stud that separates the stud from the housing itself. Somehow, some way, shape, and form, this got way too hot, and that caused that insulation to melt. And so this goo is that what we're seeing is that there is a, you know, castle style lock washer underneath that bolt, and so that's the goo leaking around that lock washer, and so that's why it looks like that. But the way that this sucker works is that you've got this plunger in here, which I'm assuming goes pushed up and down, and it's got a spring on it, like so, which is holding up this metal plate, like so, and when you energize this, it pulls this plate down, which makes contact on both sides, which shunts power through the solenoid. That's the way this sucker works. You know, regular solenoid stuff. So, for whatever reason, this melted, and when this melted, it caused this to stay in partial contact which is why it was leaking voltage through it. And additionally, it was probably also not letting like any amps through, which is why we were only seeing about 20 volts coming through it. So it was creating a partial blockage for the voltage flow, which is probably what caused this to overheat, which then caused this thing to melt. Additionally, when I was taking this off, these wires on here were loose enough that I was able to turn them by hand. Like, not like loosey-goosey, but I could put my thumb on it and move it, which was probably not helping with this making good contact. So it was a cascade event. Something caused this to overheat, which caused this to melt, which I think just the way this is set up caused everything to shrink in just a little bit, which I think then caused those lugs to become loose, because, you know, I think this guy basically sucked itself inward because there was, you know, tension against this rubber thing. And when the rubber thing melted, it caused the whole thing to shrink, which then caused this to cause there to be no longer tension between this nut and this nut on the lugs. So then the lugs became free, and that probably caused it to snowball from there. And that's probably why it just suddenly stopped going, is because these lost contact. So there stopped being enough voltage for the golf cart to move, which is probably a good thing, because when those lost contact, it kept this thing from catching fire and setting the golf cart, you know, into a great burning bonfire. But anyway, that was the failure point. This insulator melted, which then caused everything to lose contact. So interesting, but I digress. All right, so I actually just decided to go ahead and clean things up. So the only things that are actually moving power in here are these two copper lugs and this copper washer. Everything else is just mechanical linkages to basically make this stay up when it needs to be up, and then make it go down when it needs to go down. And then, of course, the coil in here that shunts everything. And as we saw, the coil works just fine. The whole plunger mechanism works fine. But what was happening is, I believe this sucker was stuck up here, and it was shorting to the case, which was shorting to ground. And then in addition to that, it just wasn't moving all the way down, and it wasn't making full contact. It was probably actually the lugs that were the reason why it wasn't getting full voltage through there. So I'm just going to put the sucker back together and throw it in my parts bin. And if I ever need another one of these solenoids, or I just need a solenoid for something else at a later date, I'll have this ready to go. Although it is a 36-volt solenoid, so I don't know what else I'm going to use it for other than a golf cart. But I digress. We shall see. But I'm going to slap her back together, and I'll be able to throw this in the parts bin as an emergency spare part in case I ever need it. All right, so there she is, all repaired. And sorry to say that was actually a fix to a previous fix that was a workaround to a failed OEM part. So I don't know how applicable this is going to be to most people. But at the very least, you know, a solenoid that'll work to, you know, do the same thing if you have that OEM solenoid that's failed. I can't tell you what the resistors are on there. The current setup works on this thing, but someone's been in there and they monkeyed with the wires. So I'm just recreating their past work. I'm not trying to get this thing back to the original spec. So this may not be as helpful of a video as I thought it was, so I apologize for that. But anyway, I digress. I hope this video helps. If it did, consider giving the video a like. Comment down there. Let me know if you're still rocking that OEM solenoid. I can't really help you out too much there, but to the best of luck to you. And if you want to see more work on this golf cart, because it's becoming a annual tradition at this point that I fix my cousin's golf cart on Thanksgiving and Christmas, you got to subscribe. So smash that big gray button over there. Till next time, I'm out.